We are going to be writing equations of parabolas given certain information. So before we do that, I wanted to review the different forms. So we have standard form, which is probably the first form we learned, which is y equals ax squared plus bx plus c. We also have factored form, which is exactly what it sounds like. It means that it's been factored. So we have y equals a times x plus b times x plus c. And those b and c are just variables to represent unknowns. And then we also have vertex form, or graphing form, which is y equals a times x minus h squared plus k. All right, so and obviously we know that HK is equal to the vertex. Okay, so given certain information, we want to write the equation of parabolas, and we're going to assume that A, which is the stretch factor, is equal to 1. Okay. So the first example we are going to look at is we are given that the vertex is 2, -5. Now when it says write the equation of a parabola, it doesn't specify the form. So what we want to do is pick the form that makes the most sense. So since we're given the vertex, and again, we know that this is very important, a equals 1, so we don't have to worry about that. So we probably want to put it in vertex form because we're given the vertex. So it would be y equals, a is just 1, and then it would be x minus 2 because the h is x minus h, so it's always the opposite, squared, and then minus 5. And that's it. All right, let's look at another one. What if we are given this time that the x-intercepts are -3 and 4? So again, you want to think what form would make the most sense with what we're given. So we learned recently that the x-intercepts have to do with factored form. So that would probably make the most sense for this. So it'd be y equals, since it's -3, if we were to write that as a factor, going backwards, it would have been x plus 3. And since it's 4, if we were to write that as a factor going backwards, it would be x minus 4. All right, so pretty easy. So now, what if we specify that it has to be in standard form? So write equation of parabola in standard form. So then it makes it a little bit more complicated, but the nice thing is we can actually start with how we just did it and then transform it into standard form. Okay, so our first example, we are given that the x-intercepts are x equals -5 and x equals -1. So again, we want to think what form makes the most sense, and I feel like because we're given the x-intercepts, factored form would make the most sense. So we would do y equals, and then we are going to transform it back. So it'd be x plus 5, and then times x plus 1. Okay, so from there, what we can do to put it in standard form is just multiply it out, because standard form is just all simplified. So we're going to multiply it out. So to do that, you can use the box or distributive property. So x times x would be x squared, x times 1 would be x, 5 times x would be 5x, and 5 times 1 would be 5. So this would end up being x squared plus 6x plus 5. And that is the equation now in standard form. And then we were just given the x-intercepts, but we were able to put it in factored form first and then transform it into standard form. I'm going to make this a little bit harder using that same problem. What if I want it to be in vertex form? So we have to think, okay, we have our two x-intercepts. What we've learned is that the vertex is halfway between the x-intercepts. So what we can do to put it in vertex form is find the vertex. So to average the x-intercepts, you add them together and divide by 2. So we would get -6 divided by 2, which is -3. So far we have the x value of the vertex. To find the y value, you can plug it in. So you can actually plug it in to this equation right here or this one. It doesn't matter. So I'm going to plug it into the second one. So -3 squared plus 6 times -3 plus 5. So -3 squared is 9. 6 times -3 is -18 plus 5. So 9 minus 18 is -9. -9 plus 5 is -4. So now we know our vertex is -3, -4. So we could easily put that into vertex form. It would be y equals, and then because it's -3, it's going to be x plus 3 squared minus 4. So that would be in vertex form. Okay, let's go ahead and try another one. This time, again, we're still going off of right equation of a parabola in standard form. So this time, this should be very easy considering we kind of just did this for our second part. We're given that the vertex is -1, 2. Okay, well, we can't just go directly into standard form, but we could put it in vertex form and then from there put it in standard form. So to put it in vertex form, this would be y equals x plus 1 squared and then plus 2. So then we have to think, how could we put this into standard form? Well, we can multiply it out. So remember, x plus 1 squared does not just mean x squared plus 1 squared. What it actually means is x plus 1 times itself. So x plus 1 times x plus 1 and then plus 2. So I'm going to use distributive property. So x times x is x squared. X times 1 is x. 1 times x is x. And 1 times 1 is 1. And then we have that plus 2. So when we combine like terms, we get x squared plus 2x plus 3. And now we have it in standard form. So is that if we just have, assuming a is not equal to 1. So let's just say I give you like the x-intercepts are 2 and 0. So I'm kind of going on a little bit of a different topic here. So let's say our x-intercepts are 2, 0 and -2, 0. And that's all I know. I don't know that a is 1. Is that really enough information? So let's kind of see what possible graphs that we can have with this information. Okay, so we could have our x-intercepts at 2, 0 and -2, 0. But because we don't know our a value, we really don't know the steepness of the parabola. So it could be here in our parabola, could be something like this. It could also be something like this, where it's upside down. It could also be something like this, where it goes even steeper. So we can see by not having an a value, it doesn't give us enough information to actually accurately write the equation. So in order to find the full equation, if we do not know the a value, we need at least one other point. So we're just going to try an example of that. So we want to find the equation of a parabola with vertex 2, 5 and passes through the point 1, 8. Now, the reason I have to give another point is we don't know the a value, and the a value, once again, is the stretch factor. It tells us how steep it is, or maybe if it's upside down. So what we're going to do is, again, it doesn't tell us the value or what way to write it in, so I'm going to write it in vertex form. So y equals, we do not know a, but we know the vertex, so I can plug in my vertex. Now think about when we worked with lines to find the equation of a line. If we had the slope to get the b value, we can plug in points to find that. Well, we have our point 1, 8. So I'm going to plug in the 8 for the y, and then I'm going to plug in the 1 for the x. So we get 8 equals a. 1 minus 2 is -1. Okay, so remember that -1 squared is connected to the a, so we can't combine those two terms. So -1 squared is 1. 1 times a is a. So we have 8 equals a plus 5. We could subtract 5, and we end up getting a equals 3. So now we have y equals 3 times x minus 2 squared plus 5. And that gives us the entire equation with the 8 value.